In the intro to Chapter 7 notes, we're going to do a couple of things. One, we're going to look at area of some figures, and then the other thing we're going to do is some more work with inequalities and some graphs with those that will continue to be a part in what we do in Chapter 7. Okay, area. Remember, area is a number that tells us how much space something covers up. So let's say we had a rectangle here that measured 4 units by 2 units. Well, if it's 2 units long this direction and 4 units long this direction, the area would be how many little square units it took to cover it. So if it's 4 this way and 2 this way, 4 times 2 is 8, and the area of this rectangle would be 8 square units. Okay. Now, most of us understand, length times width is area of a rectangle, but what happens when we get some strange looking shapes like this? We do not have a formula for the area of this particular shape. So what we do is we split it into parts. We say, hey, look, there's a big rectangle, and then there's a little piece of it missing right here. So we can find the area of the big rectangle, and we can subtract off the area of the small part right here that's missing. Okay, so in other words, we're taking the big, pretend it was full, find the whole area, and then subtract off the part that's missing. So for the big one, it would be 30 by 15, because those are the dimensions of the whole thing, minus, and then this little small part that's missing is 8 by 10. Well, 30 times 15 is 450, and then we subtract off the 8 by 10, which is 80. And when we do that, we'll get 370. So the area of this piece, this figure that's here, is 370 millimeters squared. And I put the little squared on there to show that it would be how many squares it took to fill this whole space. Okay. This one, similar idea. We could do the big one minus the little sliver that's missing. Or, just so I can show you a different way to think of it, we could also maybe split this into parts and say, hey, let's do the area of the sideways one and then add on the area of the little vertical piece down here. Okay, so this part at the top measures 13 by 6. And then we would add on this sliver at the bottom. Well, this little sliver down here at the bottom, this side is 7. But this side is not marked. So what you have to think about is this little piece right here and this little section here that's marked as 8 would add up to be this length right over here. So 13 for this minus 8 here would leave 5. The 5 here and 8 here would add up to the 13 there. So this little sliver here is 5 by 7. 13 times 6 is 78. And then we add on this other region, which would be 5 by 7, which is 35. That adds up to a total of 113, and it's in meters squared because our unit here was meters, and we're measuring in square units. Okay? All right, some more with inequalities. What they're going to have us do next is talk about something called interval notation. Interval notation is a way of expressing inequalities, okay? Except we use either parentheses or brackets or sometimes a combination of the two. We use a bracket when the number actually gets to that value, and we use a parenthesis when it gets close but doesn't touch. All right, so let me show you what I mean by that. So they're saying x is greater than 3.4. On a number line, 3.4 would be right here. They're saying x is greater than 3.4. That means x is larger than 3.4. X will be over here on the right. X could be 3.5 or 4 or 17 or whatever, and it could go forever this direction. X is greater than 3.4. That means it doesn't equal 3.4. We can't put an equal sign on it. Doesn't have an equal to. So it just means as soon as you barely get past 3.4, 3.41 or whatever, you're good. So this would be our number line inequality. Our number line, sorry. Here's our number line. Here's our inequality. And then the interval would be, hey, it starts at 3.4 and it goes to infinity. It goes forever to the right. I'm going to put a 3.4 in parentheses, so 3.4 there, to indicate that it did not have an equal sign. The number 3.4 is not part of this inequality. It's not part of the number line. It's not part of our interval. And then infinities are always going to have parentheses because you never actually get to infinity. It keeps going forever. It goes to a million, a billion, a trillion, but it keeps going beyond that. So infinities are always going to have parentheses because you never actually equal that number. Okay? All right, number 4, x is less than or equal to negative 3 on a number line graph. Here's negative 3. To the left of negative 3 would be negative 4, negative 5, and so on. To the right would be negative 2, negative 1, 0, and so on. This time they're saying x is less than or equal to negative 3. X is smaller than negative 3. And this time I'm going to put a squared off bracket at negative 3 because it does have the equal sign. It can equal negative 3, so I put a squared off bracket. All right, so this is my inequality. X is less than or equal to inequality. This is my number line. And then my interval, remember intervals tell us where the shading stops, where the shading starts, and where the shading stops. This shading started at negative infinity, and the shading stops at negative 3. Infinities always have parentheses. So I'm going to parenthesis on that negative infinity. I'm going to put a bracket on the negative 3 because it does touch the negative 3. You put an equal to, then that means you bracket that off and you bracket off your inequality. And, I'm sorry, let me say that again. If you have an equal to on your inequality, then you have a bracket on your number line and a bracket on your interval. Okay, these are called intervals right here. Okay, next inequality. They're telling us x is in between negative 2 and positive 4. You could put a number on each side if you wanted to. Okay. They are telling us x is in between the negative 2 and the 4. I'm shading all of these numbers. Now notice that negative 2 has an equal to on that inequality symbol. That means I'm going to bracket it. It can equal negative 2. The 4 has an equal to on that inequality symbol. That means it can equal negative 4. I'm going to bracket it. Okay. So we are shading from negative 2 to positive 4. So my interval is going to be bracket negative 2 to 4 with bracket. Since they both had equals on the inequality, they have brackets on the number line and brackets on the interval. Compare that to number 6, where we're shading from negative 2.5 to positive 2.5. But these do not have the equal to's on the inequality. So even though we're still shading in between those numbers, we're going to parenthesis the number line rather than bracket. We cannot equal those numbers. They're going to be in parentheses. So our interval, we're shading from negative 2.5 to positive 2.5, and they're going to be parentheses, not brackets. They're parentheses because we did not have equal to symbols. I want to make another comment about these interval notations. You do have to put the numbers in your intervals from least to greatest. So, for instance, negative 2.5 has to be on the left, positive 2.5 has to be on the right, because you have to have those numbers from least to greatest. Negative 2.5 is on the left, positive 2.5 is greater than, it's on the right. Okay? If you reversed it, like on this one, if you reversed it and put the 4 first and the negative 2 second, that would be wrong, because you have to go from least to greatest. Negative 2 is smaller, it's on the left. 4 is bigger, it's on the right. Same idea when you have the infinity symbols. Since this one started at negative infinity is on the left, and negative 3 is on the right. This one started at 3.4 and went to positive infinity. Positive infinity is the big number. It's got to be on the right. If you reverse the order, it would be incorrect. Okay. A couple more here. Notice this one has something unusual. It says or in between. So they're telling us A can be less than 5, or A can be greater than or equal to 8. So I'm going to put 4, 5, 6, 7, 8, 9. Okay. A is less than 5. That means it's lower than 5 and it's going to have a parenthesis on it because it does not have the equal to. Or A could be greater than or equal to 8. That means it could be 8, 9, 10, 11, etc. It could be bigger than 8. That's going to have a bracket on it because it does have the equal to. So when you have an or inequality, we're joining those two pieces together. It's like if I told you I'm going to give you $5 if you have an A in the class or if you may have perfect attendance. So you just have to do one of those things and you get the $5. You do not have to do both. So since they're saying or, we're going to shade the stuff that makes this true, but we're also going to shade the stuff that makes this true. All that stuff gets to go in it together. It's a union. Okay? All right, so our interval, we're going to say negative infinity, because it's on the left, all the way up to 5, and I'm going to put a parenthesis on 5. Then I'm going to put a U for union, meaning join with it, the other region. And the other region will have an 8 to infinity. Notice the 8 has a bracket on it because it had an equal to in the inequality statement. So we put a bracket on the number line. We put a bracket on the interval. This one is sandwiched in between. M is sandwiched in between -4 and -1. So I'm going to put a parenthesis on the -4. I'm going to bracket the -1. I'm going to shade in between. That's our number line. And in the interval, we put where we started shading, where we stopped shading. We started shading at -4. It did not have an equal, so we put a parenthesis. We ended the shading at -1. It did have an equal to, so we put a bracket there. Okay, now they're going to give us some scenarios, and they want an inequality, an interval, and a number line for each one. Okay, so number 9, to qualify for the clinical trial for a new medication, a patient's heart rate must be no more than 95 beats a minute. Okay, so I'm going to use B for beats. Okay, and what do I know about their beats per minute? Well, 95 is going to be the upper end, right? It cannot be more than 95. So if it can't be more than 95, that means it could be less than or even equal to 95. It just can't go over. Okay, this is our inequality. The number line, you can put a number on each side. I will be shading below 95. The heart rate could be 93, 94. It could even be 95. It just can't go above. Since we have the equal to symbol, I'm going to put a squared off bracket. And then this is my number line. And then the interval will be negative infinity up to 95, and I'll put a squared off bracket on the 95. That is my interval. Number 10, a student's GPA must be at least 3.6 to qualify for a particular scholarship. Okay, so if your GPA has to be at least 3.6, that means it could be higher. If you had a 3.7 or 3.8, that would be fine. It just has to be at least 3.6. So I'm going to put G for GPA. And here's my 3.6, and I want the GPA to be at least 3.6. That means 3.6 or higher. This is the inequality. For the number line, I'll put my 3.6 in the middle. I can put a number on each side of 3.6, 3.5 there, 3.7 there. I'm going to shade greater than 3.6, numbers that are bigger. And I will put a squared off bracket because it has the equal. My interval will be 3.6 to infinity. 3.6 has to be on the left. That's the low end with the squared off bracket for the equal to, and then it goes to positive infinity. Number 11, to become a police officer, a cadet must score higher than 83.4 on the qualifying exam. So I'm just going to use X for their score on the exam. It must be higher than 83.4, so that means greater than. I cannot use an equal to because it specifically says it has to be higher. If they make an 83.4 exactly, that will not be enough. This is our inequality. For the number line, we're shading above 83.4. It will have a parenthesis because we do not have an equal to sign. The interval will be 83.4 to infinity. Number 12, American men are considered to be of average height if they are between 70 and 74 inches tall inclusive. Okay, so we want in between 70 and 74. Our X numbers are in between there. So I'm going to say, hey, 70 is less than X, X is less than 74. Okay, X is in between those numbers. Since it says inclusive, that means it can equal those numbers. It could equal 70, it could equal 74. So there's my inequality. The number line will have those numbers on it. You could put a number on each side if you want. We're going to shade from 70 to 74. Because it has equal to symbols, we're going to bracket those numbers. And our interval, remember an interval says where does the shading start and where does the shading stop? It starts at 70, ends at 74. Put brackets on those because they have the equal to. And then the last one, the Jones family wants to spend at most $8,000 on their home remodeling project. So the amount of money they want to spend, I'm going to use M for money. They want it to be $8,000 at most. That means they're totally cool with it being less than $8,000. Or it could even equal $8,000. That's just the most they want to spend. They do not want it to be $8,000 and 1 penny. They want it to be $8,000 or less. So there's my inequality, my number line. I'm going to shade below the 8,000. I'm going to put a squared off bracket on it because it could equal 8,000. And then my interval is negative infinity up to 8,000. And I'm going to put a squared off bracket on that because it has the equal to. Okay, hopefully that helps with some interval notation, which is a new thing for us, but it does connect back to inequalities and our number line graphs.